Okay, welcome everyone. This is actually our very first webinar on content. So this is the webinar where we're actually doing statistics instead of just talking about what the course is all about. But this is the content webinar. And let me share my screen and I can talk about what we're doing. Okay, so the plan today is I'll start out, and I'll always start out this way, is with questions if you have questions. And that could be, at this point, it's probably about the course itself, since we really haven't done anything yet in terms of doing any statistics. That will change in a minute because we'll be doing statistics. And then what we're going to do today is we're going to start with chapter 1. Chapter 1 is all about basically how to set up a survey and how to conduct a survey and how to do it right so that you actually have good data. So we're going to be talking about variable types. We'll talk about sampling, and we'll talk about statistics, which I know that sounds like that's the whole name of the course, but we'll define what it means for something to be a statistic. And then we'll also get into charts. So today we're getting into what is called descriptive statistics, which means we conduct a survey, we look at it and we say, yeah, that looks good. We don't make any decisions. So we'll change that in a couple of weeks and we'll start making decisions based on statistics. And we'll talk about when you can make decisions. But right now we're just going to be talking about, let's look at a survey, look at data and say, yeah, it's pretty. So we'll stop there. And most of you, or I wouldn't say most of you, but some of you have already had maybe all of this, especially if you're younger. And you may not know what I'm talking about, but statistics, in particular, descriptive statistics, has been part of the Common Core standards in the last probably 7 years. So if you went to school in the last 7 years, in K-12, I mean, then you've had this stuff. If you haven't, then you may not have had it. But it's very important, and we'll talk about that. So that is the plan today. And as I mentioned, this is our very first regular webinar. So, this is not about the course. This is about statistics and content. And so I'm going to be doing statistics, defining things, showing you examples, all that kind of stuff. But that doesn't mean I can't answer questions if you have questions about the course. So are there any questions about anything? And again, this is a great time. While you're thinking about it, or maybe typing in the chat box, because I do look at the chat box, by the way. I always have one eye on the chat box. I want to remind you that what is the one main thing you definitely need to do this week to get ready for the next 3 weeks? Anyone know? Get a project partner, or 2 project partners is better. So at this point, this is where you should be getting project partners. I watched the discussion board, and there are a lot of you that have already either found a project partner or at least posted. But if you haven't, you need to, because it'll be a disaster if you don't have partners. So that is something you should do right away. You don't need to know anything really to get the partner. You just need to know how to type and say, I need a partner. And that's it. And find 2 other people. I don't expect you to know each other. That's okay. You'll get to know each other as class goes on, but especially as you work on your project, because that's when you really get to know at least a couple students in the class. But if there's any questions about that, I can help you. Any questions about anything? Okay, if there's not questions, what I like to do is keep it current. So I like to, instead of just, give you definitions and theorems and some rote examples, I like to talk about, what I find in the news. And in particular, one of the first places I often look is our Lake Tahoe news. And I apologize if you're not from Tahoe, but you can trust me that, we do have news here. nothing too big, but so I'm going to share. This is, by the way, the Tahoe Daily Tribune, which is one of our main news, used to be newspapers, but I don't know if they do paper anymore, but our news group or whatever. And if you scroll, one of the things the Tribune does is it does a survey. And as I mentioned, this class is all about surveys. It's all about surveys and then understanding how to interpret the results and then come up with conclusions and stuff. So the first thing is, let's read it. Okay, it says, have you started your spring cleaning and defensible space yet? And by the way, that's things like moving the pine needles away from your house so that you don't have if a fire happens, your house doesn't burn down. That's one of the biggies, and there's some others too. But if you don't know what spring cleaning is for Tahoe, that's what spring cleaning is. And if you look outside, we don't have a lot of snow anymore. So the choices are yes, my neighborhood is FireWise certified. And then yes, I have a dispensable space and have taken the steps to harden my home. And no, but I plan on doing it once more snow melts. And then finally, no, I never do anything. Okay, just wanting a fire, I guess, and wanting your house to burn or something. So I'll let you post, especially if you live in Tahoe. Tell me what your answer is. And if you don't live in Tahoe, if you live in a fire-prone area, especially, then you can tell me your answer too. That'll count. Anyone live in Tahoe? There's a bunch of you. It's got to be some of you. I'm watching the chat box. I'm seeing a blank chat box. So, by the way, these are very interactive. Okay, live in Tahoe. Now the question is it yes? Is it the first one, the second one, the third one, or the fourth one for your answer? So, do you never do anything for dispensable space? Are you FireWise certified? The second one. There we go. Okay, Monterey County fire area. Yeah, nowadays, like most of California's fire area, unfortunately, kind of bummer. So the answer is 2. Second one. Okay, so I'm going to answer 2 because we have more than 2, and looks like number 2 is more people. And actually, I'm a number 2 also. I've taken some steps to harden my home or move some pine needles. Okay, and I'm going to vote. Okay, so here we go. 48% say no, but they're going to plan on doing it once the snow melts. 27% are yes, and they've taken steps. That's it. Okay, and etc. So a few questions. The first thing to look at is I want to look at the survey. And you'll notice, and this is very important for this entire course, by the way, is that the answers to this survey are words. Any questions on that? So hopefully that's obvious, right? You click one and it's a sentence or some words. Okay, when the answers are words, we call that a qualitative study. So qualitative means word answers. Like, and yes, no is a special kind of qualitative, by the way. This is not a yes, no. This is there are 4 different things you can say, but this is definitely qualitative. Okay, on the other hand, the opposite of that is if your answers are numbers, then we call it quantitative. So numbers are quantitative, words are qualitative. Okay, and in this case, this is a qualitative survey question. Can you think of a way of kind of restructuring the way this survey was done so it's quantitative? Any thoughts? Any thoughts? If you can't, then I'll let you know, but I always like to see if any of you can come up with one.
I have an idea. Could you say how much time have you spent preparing your house for fire?
Great. Okay, actually, I would say fire protection, hopefully.
Yeah.
Yeah. So how much time would definitely be quantitative, because the answer, and you always want to think about what is the question and how would somebody answer it? Or if it's not a person, what data would you write on a piece of paper when you wrote down the answer? And in that case, how much time have you spent? So I've spent about 30 minutes. I haven't spent that much time yet. I'll do more later. One thing about Tahoe is it never stops. We get pine cones and pine needles falling all the time. So the time always keeps going. But how much time is a great example. Let me give you another one. And that would be on a scale from 1 to 10. With 1 being no, I never do anything and never will. 10 being I am super certified and that's what I think about every day. How much effort have you put in to spring cleaning and defensible space? So scale of 1 to 10 or scale of 1 to 100 could be done. It doesn't matter what your scale is, but a scale. And that makes it quantitative also. What do you think if you're going to be doing statistics and you're going to be analyzing it? Do you think quantitative or qualitative is better if you have a choice? Any thoughts?
Probably quantitative.
Yeah, quantitative, because quantitative, you can actually do the math. It's pretty hard. There's not a whole lot of math you can do with qualitative. Okay, we can get the proportions of people, but that's all we get. Whereas if it's fully quantitative, there's all kinds of stuff you can do from a study. And we're going to be spending some time today and for the rest of the entire quarter. That doesn't mean we don't do qualitative. Qualitative does happen, like in this case. And sometimes there's no choice. So if the survey question was, I don't know, what is your ethnicity? There's no way of making that quantitative. Okay, you can't do that. Okay, there's no number answer to any of those. So that would definitely be qualitative. So some things are qualitative and there's no choice, but sometimes you can make it quantitative. Any questions on the idea between quantitative and qualitative? Okay, the next thing I want to look at the survey is we've got, in terms of the people who voted, 109 people voted, including us, by the way. Okay, and we only count as 1 because I just clicked once. Okay, just a note, I see you saying you want to check in. I don't take roll. Towards the end, we'll have a secret word quiz. So, and I never give it in the first 5 minutes, by the way. So you don't have to worry about that. But if you have a question about anything, you can always ask as we go. Just let you know that. Okay, so we had 109 votes. Okay, and does that mean that we have a really good idea of how the residents of the Lake Tahoe area are dealing with defensible space? Okay, so can we say that almost half of all people in the Lake Tahoe area plan on working on defensible space once the snow melts? Can we say that? Okay, what's the problem with saying it? Because I see you say, no, we can't. What's the problem with saying that almost half of all people in the Tahoe area? Yeah, the big issue is that first we have a sample of 109, and it's 109 out of, in the whole Lake Tahoe area, there's probably 40,000 of us. Okay, so it's not a gigantic sample. It's not tiny, it's not like 10 or anything, but it's not gigantic. But the bigger issue is who answers this survey question. So a very special kind of person is going to answer a question, this particular survey question. So obviously the only people that would answer are the people who have opened up this link. Because if you haven't opened the link, you can't answer it. And that already tells you a certain kind of person. Then it's the kind of person that actually answers a survey question when they open up a link, when they're not even asked to do it. Okay, and that's a big deal. And my guess, maybe I'm wrong, is that people who would answer this probably are not the same ones that never do anything, right? People who are kind of lazy and don't answer are probably lazy and don't protect their house for fire either. Maybe I'm wrong, but it's just a thought. When the sample is not representative of the population, we say there's bias. And bias is a big deal because you want to use your sample to get a good idea of the population. Any questions on that idea? Any questions? So you really want to use a sample to get a good idea of what the population is. And that's hard. By the way, could they ask the entire population? What do you think? Could they just get the whole population? Is that something they could do? Okay, I see some of you shaking your heads. I don't see anything in the chat box, but not a chance. Okay, this is just a news group. You know what I mean? Do you know how much work it would take to ask every single person in the entire Tahoe area and make them answer? Okay, it's never going to happen. So you can't get the population. All you could do is get a sample. So one thing you might say is, could they have gotten a better sample? Could they have done it with less bias? Any questions on that idea? And what we're going to talk about next is the different kinds of sampling techniques that you could do to prevent bias. Because there are sampling techniques where you end up not having bias. Now, it does not mean that if you have no bias, does not mean the sample is exactly the same as the population, because random things can happen. If I flip a coin 101 times, am I going to get half heads and half tails? What do you think? If I do it, without any bias or, cheating, if I flip a coin 101 times, am I going to get half heads and half tails? Okay, not a chance. Not a chance, because half of 101 would be 50 and a half. It can't even happen. Okay, so there's always going to be a little variety or variation, even if there's no bias. Is that clear? So there's kind of two types of error in a survey, okay, or sampling. One is when there's bias. Okay, a good example, one I love to use because it was so amazing when it happened, is if I want to look at the height of average students, and let's go average male students because it's more interesting for this example. You'll see in a minute. So if I want to look at height of average male students, and I decided to take the first class I ever taught, okay? And I bet none of you could guess what that average height was. Okay, I can see you guessing, but what do you think the average height of my first class was for male students? Okay, it was 7 feet. Okay, I knew no one would guess. Okay, you might be able to guess why. And that was because the coach of the UCLA basketball team had all of his students, all of his players take my class. And that was all the males in my class. And that was about as biased as you can possibly imagine. Do y'all agree? So this is why you want to do everything you can to avoid bias, because that would be absolutely ridiculous to say, well, that represents everyone and the average height of male students is 7 feet. Okay, no. Okay, so you got to be very, very careful about bias. Any questions on that? So I want to talk about the different sampling techniques. And first, maybe I'll remind you, since I got it written, because it's good to see it written. And that is quantitative, means that the outcomes are numbers. And that qualitative is the outcomes are not numbers. Okay, very simple. The most important thing to note is that it's the answer to the survey question, not what you're interested in learning. So if you're interested in learning, for example, what proportion of Americans voted in the last election, is that quantitative or qualitative? Okay, this is where you have to be very careful. So the survey question that you're going to ask each individual person in the study is, did you vote in the last election? You're not going to ask what proportion of people voted in the last election. You're going to ask, did you vote in the last election? They're going to say either yes or they're going to say no. Okay, you're interested in the proportion of people who said yes, but the answer to the survey question is either yes or no. Okay, so if 70% of the people voted in the last election, the survey question was not what percentage of the people voted in the last election, but did you vote? So you gotta be very careful about the quantitative versus qualitative. It's not what you're interested in finding out, it's what the data answers will be. Any questions on that idea? And that's a big mistake that people make. And I will let you know that I would say of all things in this class, that might be number one. In terms of, if you get that wrong, if you can't do that, you won't be able to do about half the questions in the entire course. So you have to be able to think that way. Think about, what is the survey question? What is the answer to the survey question? Not what are you interested in finding out about. Do you see the difference? Any questions on that? Okay. On the other hand, if you said, I don't know, how many minutes did it take for you to fill out your ballot? That would be quantitative. Because, I took 35 minutes to fill out my ballot, something like that. Any questions on that definition? Okay, and then one more thing that I want to get to before I talk about sampling technique. And that is, if you're talking about the sample and you're getting a number from that, and the number could be things like the maximum, the highest number someone said, or maybe the average, which we're going to call the mean. From the sample, that's called a statistic. If it's from the entire population, it's called a parameter. Any questions on that definition right there? It's not a hard definition, but you got to remember it. And I should warn you, by the way, chapter 1 is pretty much all definitions. It's not going to feel like a math class at all. Chapter 2, we'll start getting numbers, and we're doing both today. But chapter 1 is pretty much all definitions. So a lot of vocabulary. Read the book also, because that goes through and gives examples and also defines the things we need. And
I have a question. Was the answer to the question, was it quantitative or qualitative?
Which question?
It was the one regarding that it was asking for, it wasn't asking for a number, right? It was asking for.
So you're talking about
yes or a no.
You're talking about this question here?
Well, the last one, yeah.
You're talking about the
one with the quantitative and qualitative.
Well, you're talking about the voting one.
Yeah, the voting one.
Right.
What was the question again?
So what you're interested in finding out about is the percentage of people who voted.
Okay, so you would obviously
survey question.
You may or may not be finding a number. Okay.
Right, but you're not going to find a number from each answer because the survey question.
I'm just going to say yes or no. Yeah.
Exactly.
So it's that means that it's the one that's non-number. What is that? Qualitative?
Qualitative.
Okay.
So qualitative means that you don't have a number answer. Quantitative means you do
statement.
have a number.
Okay.
Yeah.
Okay.
Yeah. Yeah, and those are just definitions. Okay, and very important though, like I said. So I'm glad you asked because this is a biggie. Whereas statistics and parameter, that's more of a minor definition. I'll be talking about it once in a while, but that quantitative, qualitative, you got to know. Okay, get that down. Okay. Okay. I'm not saying you shouldn't learn parameter and statistics, but qualitative, quantitative, that's the biggie in the whole class. Okay, or one of the top 5, I'd say. Okay, any questions about statistics and parameters? So again, parameters is for the population, statistics is for the sample. And I want to let you know that typically you can't get a parameter. So what you can do is you can guess at a parameter, you can estimate a parameter, but usually you can't actually know the parameter. You can just talk about it. Okay, so if I asked you, what is the average age of all Americans? You'll never know exactly. Does that make sense? It would take you a long time to start surveying every American, and by the time you're done, years will have gone by and they have different ages. Okay, but a statistic you can get. You can do a survey of 20 people and you know their age. Any questions on that idea? So we use a statistic to guess at a parameter, to get an educated guess. And that's what this class is all about, is using statistics to get an educated guess of a parameter. Okay, so now let's get back to think about how do you do a survey. So here's some ways. And the first would be great if you could do it. And sometimes you can, but usually you can't. And that is random sampling. So random sampling means every individual is equally likely to be surveyed. Okay. And the individuals don't have to be people, by the way. Okay. They could be dogs. If you're watching the dog and you want to find out, I don't know, how much they eat. So that individual doesn't have to be a person. Okay. It doesn't even have to be alive. It could be weather. So the individual would be an individual day. And you say, what is the temperature on that day? The high temperature. Okay. So that's just a note. When I say individual, don't necessarily think person. Okay. So do you think random sampling is easy to do?
No.
Okay. It's usually impossible. Let's try something. All right. And everyone needs to put this in the chat box. It'll be very fast. What I want you to do, and don't put in the chat box until I tell you put it in. You can put it in, but don't hit enter until I tell you hit enter. I want you to pick a random number, a whole number, from 1 to 10. And I'll give you 3 seconds. Get in the chat box. And when I count to 3, I want you to hit enter. Okay, 1, 2, 3, hit enter. Okay, what I have learned, so if you truly did a random sample, then there should be an equal distribution of numbers between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. No one ever picks 1 and 10. And it didn't happen. Okay, no one ever picked 1 and 10. You don't have the ability. And I'm not saying you're dumb or anything like that. It's called you're human. And humans do not have the ability to even pick a random number. Okay, by just writing one down. So that even didn't happen. And that was something as simple as picking a number. Okay, if you had to pick a random number and you get to think about how to do it, do you think it's possible to do it without doing it just by picking out of your head? What do you think? Yeah, exactly. Use a computer. And in fact, if you have a smartphone on you, just ask your smartphone, pick a random number from 1 to 10. It'll do it. Okay. Smartphones are great. I don't know if you've ever tried that, but the smartphone does that. It will hear you say that and it'll give you a random number from 1 to 10. And that actually is accurate. Humans are not good at picking that random numbers. Smartphones are. Okay. And computers are. In fact, my very first computer app that I wrote for LibreText, so the first in line is random numbers, and you can get a random number. So, but on the other hand, it's really hard. If you want to pick random people, let's say you wanted to pick 50 random Americans, could you do it?
Sure.
Is it even possible? Any thoughts? Any ideas? And I'll even make it easy for you, adult Americans. So I want to mention, by the way, it's against the law to survey children without all kinds of processes. So whenever I say we're gonna survey, we're always talking adults. I don't want anyone to go to jail. So do you think you can pick random people, 100 random peoples in America? Okay, the answer is not even possible. Okay, you can't do it because the only way in theory to do it would be to somehow get every person listed, put them all on a computer, and then have the computer pick. And you can't get every person listed. Good luck. Okay, so you can't do it. So just to let you know, random sampling is often impossible. Okay, especially of people. You could do, say, if I asked you to pick 10 random days from the year 2020, could you pick 10 random days from the year 2020? What do you think? Any thoughts? Do you think you could pick 10 random days from the year 2020? Okay, you'd be biased psychologically if you did it off the top of your head. But the answer is we can. So the first thing you have to know is that last year was a leap year. So there are 166 days in the year. And you just have a computer pick 10 numbers from 1 to 166. And there you go, you got your 10 random days. Does that make total sense? So we can pick 10 random days from the year 2020. Any questions on that? But people are different because we can't list them. So if you can list them all, you can do random. But if you can't list them all, you can't do random. Any questions on the idea of random? Okay, simple random sampling means that every group of n individuals is equally likely to be surveyed. Okay, so simple random sampling is actually more specialized than random sampling, it turns out. And that especially comes up when you want to have to make sure that, say, you have gender balance. Okay, where you want to make sure that when you do your survey, you don't overrepresent men or overrepresent women or overrepresent trans, I guess. So if you're going to do gender balance, it's not simple random, even if everyone has the same chance of being surveyed, because you can't end up having all men. Any questions on that? So they're slightly different, simple random and random. Any questions on types of those types? Okay, when you're doing a survey of people or many other things, you know, almost anything that's alive, random doesn't happen. So you need to come up with another way. Can you think of it? If you wanted to survey people, I'd say Tahoe, but I'm gonna let it be your community. And you wanted to reduce bias. So you wanted to try to not just pick your friends, because that would be really biased. Then how might you do that? How might you reduce bias? What are some ways? Any thoughts?
Like if you were able to get the public record information from your county, like what percentage of people, certain incomes, like ethnicities and all that, and then try to get that represented percentage wise in your sample.
Great. And what you just did, you just nailed the next idea. So that is actually what you just said is an example of what's called stratified sampling. Isn't it awesome when I ask a question? And by the way, I didn't pay you to do it, So if all of you think, but that is exactly what we're talking about next. And that is called stratified sampling. And that is where you make sure that you don't have bias based on something like income or gender or political affiliation or race, okay? Or whatever it is that you think might have bias when it comes to doing the study. So here's the steps. It's a step-by-step process for stratified sampling. The first step is determine the strata. And you usually say, well, what do I want to try to avoid a bias of? Okay. And typical are race, gender, income, political affiliation, and there's others. Can you think of any others that you might avoid bias based on? There's definitely a lot more. Any thoughts what other strata might be important? Any thoughts? Besides race, gender, income, and political affiliation? Okay, and I'm talking about people.
Maybe like orientation, like sexual orientation, maybe.
Okay, sexual orientation definitely could be a bias. So you would go and research the percent that are different sexual orientations, and then you would make sure that you don't have bias on that. Okay, and that's definitely one. Another is age, because how old you are might determine all kinds of things. But you can go on and on. What type of place you live in, that might matter. So whatever you think matters is what you decide on. Okay. Then what you do is you research the percent of each group. Okay. And the good news is, unlike when I first taught this class, is you can usually just go online and look. When I first taught this class, if I said, go to the internet, people would say, internet, what's that? Believe it or not, I've been teaching a long time. But nowadays, you just go to the internet and you can find almost anything. Isn't it awesome? Okay. And you find the percents for each of the group. So if you're doing it by race, you find out the percentage of Hispanics, find out the percentage of Caucasians, find out the percentage of African Americans, etc. Whichever ones you think are the big ones in your community, and then you put other for the rest. And then you go look it up, find out how much of each there are, what percent. Step 3 is you multiply the percentages by the sample size. So let's suppose that you had enough time to survey 1,000 people, and you found out that 52% of California was Hispanic. Well, then you do 520 for your quota for Hispanics. Any questions on that idea? Okay, and then finally, you collect the data using the quotas. So what you do is you survey. You first ask, what race they are or whatever it is that what your strata are. And then as soon as you've reached your quota, let's say, you had 520 Hispanics you wanted to ask, and you got 520 Hispanics. If the next person said I'm Hispanic, you say, thank you for your time, and you don't ask the question. And that is called stratified sampling. Okay, and I would say it is the #1 way of sampling for avoiding bias in the real world for people. Any questions on stratified sampling? Okay, so the next type of sampling you can do is called cluster sampling. And cluster sampling is done in lots of different examples. And what that involves is selecting several representative clusters and then surveying every individual in each cluster. So if I wanted to survey college students, what are the natural clusters?
Freshman, junior, sophomore, senior.
Okay, that sounds good.
What people are
But-
studying, maybe?
That sounds good too, but let me start with the freshman junior. Okay, that would mean you'd have to survey, you'd have to pick a couple clusters and then survey all of them. Well, if freshman was one of the clusters, we'd have to survey every freshman, and that's too hard. Does that make sense?
Yes.
And same thing with what they're studying. If you had to survey every single student who is studying humanities, good luck. It's too many. So that's a natural. So these are clusters that are like where you can actually ask everyone in the cluster without too much difficulty. Any thoughts? There's one that's very natural and it's done all the time. I don't see y'all jumping in when I say it. I think you'll say, of course. After school programs. Well, the problem with that is then you're biasing by after school students. Okay, so you're thinking, I was talking about college students, and there's no such thing as after school for college. But even for kids, that would only grab in the kids that have after school programs, and you're missing out on those that don't. But for college students, all right, maybe I'll just tell you. Classes. So what you do is you say each class is a cluster, and I am going to pick maybe 10 representative classes at the college. So I'm going to pick a math class. I'm going to pick a history class. I'm going to pick maybe a culinary class. And I want to make sure that they're representative of the kind of students we have at the college. Then I'm going to go into the class. I'm going to hand the survey to everyone in the class. And then I'm going to ask. Okay. And of course, nowadays you have to go online.
I have a question regarding that, and then I'm not sure if we can ask questions as we're going along.
No, you can always ask questions.
Okay, so I guess regarding what kind of questions would you ask the culinary students, and then maybe
Okay, so you're not asking a different question for each class. It's the same question. So let's suppose I wanted to find out how many hours students work, okay, for pay. So for their jobs. And I want to learn how many hours they work in, let's say, Lake Tahoe Community College. So then I would go to a culinary class and I'd ask them, how many hours do you work? And then I'd go to a math class and I'd ask, how many hours do you work? And I'd take all of the answers and put them in one big column. And then I'd learn about how much hours people work or students work. Does that make sense? So it's not a comparison study. It's just using the clusters to make sure you don't have bias. Does that answer your question?
Yes, thank you.
Yeah, so it's not different questions for each cluster. It's you're learning about one thing and you're going to 5 different classes to ask that question. Okay, any other questions about cluster sampling?
How do you know how much is enough cluster sample? Like what's the difference between just surveying 2 class versus surveying 10 class?
Okay, it's a really good question. And I got bad news for you. We're not ready. And by the way, not just cluster, but stratify too. You remember in step 3, you multiply the percentages by the sample size. Well, what's the sample size? I should write sample size. How do you know which sample size to pick? And we're going to learn about how to come up with a proper sample size in a few weeks, about 3 or 4 weeks. So sorry if I can't answer that question yet, but hopefully you understand that there's a lot of math involved. And we'll get there, I promise. Sound good? Okay, but it's a good question, which means you're not responsible for it this week. but you can trust me that there are ways of coming up with how many you want to do. Okay. Okay, then there is systematic sampling. And systematic sampling especially works in business where, so let me give you an example. It might be a little boring, but it is an example I did personally. And it was from one of my students, my former students. And he ended up getting a company where he manufactured towels for hotels. Okay, this is a true story. And he wanted to be able to show that his towels were better than the ones made in China because he made them in America. And he actually came to my office and asked for some help on how to get a good sample and conduct this study. So what I asked him to do, or I told him to do, is, he certainly couldn't test every towel. What he did is he washed it several times and looked to see wear and tear based on washing. And he couldn't do that to all of them because once you've washed it many times, it's not a new towel anymore and you can't sell it. So definitely you can't do all of them. So what I had him do is take every 500th towel off the assembly line and grab those and then stick those in the wash, test them, and then see how they did. So systematic sampling means you order the population, and in manufacturing, it's very easy to order because they're ordered by how you produce. Okay, and then you survey every nth individual. An individual doesn't have to be a person, it could be a towel. Okay, so that works in that way. With students, you could do that by maybe the order by how they register. If the college was doing it, you couldn't do it because you're not allowed to get that information. But the college could do that. And the college could look at maybe every 100 student who registered for classes. And that would be systematic sampling. And that's a good way of preventing bias also. But often it's hard to order them all.
What kind of questions would you ask for some symptomatic sampling?
So any question, the question doesn't matter. It's the population that matters. So if you want to do a survey question about students, name your question, I don't care. And if we had a list of students by when they registered, we could do systematic sampling. Does that make sense?
Okay, so you're saying it doesn't matter what question you ask, just as long as there's an answer and it's the nth individual.
Yeah. And that's true of all of these. So none of these are about what question you're asking. These are about how you pick who you're asking. All of these are that way.
Okay.
Now for stratified sampling, you often choose your strata based on the bias that might happen because of that question. Okay, so if you're doing how much do you make as the survey question, then age might be a good one of the strata you might use because that matters, right? 18-year-olds make less than 50-year-olds typically because you get raises and stuff. Okay, just a note for cluster sampling, another use of it that you'll see is if you are, let's say you wanted to survey the height of pine trees in the Sierra Nevada forests. Okay, there are hundreds of millions of pine trees in our forest. Okay, there's no way you could do them all. And so what you might want to do is cluster sample, where you might grab maybe 20 different acres in different ecosystems. So one that's maybe very high elevation, one that might be on a steep slope, one that might be in an area that has a lot of water, etc. And then in each of those acres, you measure the height of all the trees in that acre. Okay, so that would be an example where you'd probably want to use cluster sampling. And so you especially use cluster sampling when logistics is an issue, because cluster sampling makes it much easier. Okay, any questions on that? Okay, and then finally, the one that you should never do if you're ever doing research that you care about issues of bias, and that is convenience sampling. And that means you just go and ask your friends, okay? Post on social media saying, hey, could you please answer my question? Okay, the Tahoe Tribune example, that was convenience sampling, the first example I showed in the news, okay? And the problem with convenience sampling, it is really prone to bias. Okay, do you think convenience sampling ever happens? All the time, and I'm hoping that by taking this class, you'll be able to look at a study that was done and be able to say that was done well, and I trust their data. And on other studies, you'll look at and say, well, that's a bunch of crap. That was done with convenience sampling. There's horrible bias in it, and I don't trust what they say. So I'm hoping that's something you'll learn about as you take this class, and especially in this first week, right away, you'll be able to read the article and say, was this done right? Let me give you another type because it's really important, especially nowadays. What is the main number one thing that has been happening and studied in the last 13 months? And if you don't know, you've been asleep for 13 months. Don't tell me you've all been sleeping. Yeah, COVID. Okay, no question about it. Okay, again, if you don't know what COVID is, you've been sleeping. Do you agree? All right, so one of the things that they had to do is they had to test the vaccines. So so they wanted to make a good study. Okay, and these are professionals. So when Pfizer or Moderna, okay, or what's the other one? Blank and blank.
Johnson and Johnson.
Johnson and Johnson, because I didn't. That was after I got my shot, so I didn't have to think about that one. I got Moderna, by the way. And Johnson and Johnson, when they did their studies, and they all did studies, then they did a special kind of study, and I want to mention it because it is a biggie, and especially this year. What they did is they got 40,000 volunteers, okay? And they used a computer to randomly select 20,000 of the 40,000. 20,000 of the volunteers got, I'll just do the Pfizer shot. The other 20,000 of the volunteers got a shot of nothing. Okay, so literally they put a shot in their arm. They said, you've been vaccinated, and they gave them nothing. Okay, I don't know if you know, but that's the truth. That's how it happened. Okay, and that is called a control study. And I figure I better mention this because that is the biggie that happened this year. So control study means you separate the population into two groups. Okay, and by the way, a randomized control study means that you did it randomly, which is pretty easy to do because you have your volunteers and you use a computer to pick. Okay, and a random blind control study, you do it randomly, and even the person giving the shot doesn't know whether it's got it or it doesn't have it. It's got some liquid in it, and they don't know what the liquid is. Okay, only the researcher knows. Okay, into two groups. The control group and the treatment group. Then
Is that just to see if there's results in obviously the people that were given the vaccination?
It's deeper than that. You do a control study so that you don't have the placebo effect, which means that if you feel like you've been vaccinated, then your activities are going to change mentally or whatever. And they want to make sure that everyone feels like they've been vaccinated, whether they are not, so they can actually get rid of that issue. Does that make sense?
Yeah, and also I wanted to say I had my first shot, and it is very true. It's almost as if it's kind of like a jump start, to be honest.
Yeah. And so again, there is such a thing as placebo, which means you feel like you're better, so you must be better, or you feel like you're better, so then you go out and party with everyone and get sick. But that's an anti-placebo. But the point is that if you don't know whether you're controlled or not.
Yeah, and I think this is probably common conversation nowadays, but it's just amazing, you know, the difference how the day before was. But I mean, it literally builds also. You know, it's an energy and an emotional catastrophe, pretty much.
Yeah. So this is done for comparison studies. especially in medicine. Okay, not everything can be done with a control study.
I have a question.
Yeah.
So, with that study, though, people have to volunteer to be in a random group.
Absolutely. Yeah, they volunteer. Exactly.
So how would the study be able to be completely random if there's like, certain people would like, not everyone across a wide swath of the population would necessarily volunteer. Like, aren't the volunteers biased to begin with?
Right. So here's the thing is that the randomization is whether you're a control or treatment. That you can do. The randomization is not who's in the overall collection of people. Okay, and it's pretty much impossible to do a full randomization in medicine, and that is because there's all kinds of ethics issues where you have to get volunteers. But what you can do is you can do a control study, so at least it gets rid of the placebo effect. That you could do, but you definitely can't. You just can't. There's all kinds of ethical issues. Okay, so it's got to be volunteer only. And that's medicine. That's called medicine. But the good news is that volunteerism probably doesn't have much to do with susceptibility to COVID. It might have a little, but not much. So in terms of the Pfizer, Moderna, they're done very well. Okay. And you could trust me again. I'll get into it more as we go in the class, actually, because again, I try and bring the biggies. And this is the biggie, right, that everyone's learning about. But I tell you, it almost made me cry last week when I read the news about the child study. It was a terrible study. Okay, so I hope a better study's done. And the reason is the sample size is too small. So we'll learn about that later in the class, but you can trust me now. It just wasn't big enough. I'm like, what were you thinking? But for the adult study on Pfizer and Moderna, and I didn't read about the J one because that happened after I got my shot, and I stopped caring quite as much. But for the Pfizer Moderna one, they were done very well. Okay.
Larry, this might not be related to our class, but I'm wondering, how did they get the percentage for efficacy? Like, how did they know it was like 94% effective? I just think it's unethical to expose them to COVID.
Easy. That's actually
okay.
easy. All they do is they test you every week. And if you don't get COVID, then you didn't get COVID. And if you got COVID, you got COVID. And they found out that for every 100 people, 94 of them were the ones that did not get that were in the placebo group, the control group, and 6 of them were in the treatment group. Do you see how that works? So that's actually pretty easy. So then you know it's 94% effective.
Can you say that again? Actually, that was
okay. So they
for me to understand.
Okay, so I'm going to make numbers a little easier, even though it's not quite the numbers they use. Let's imagine they had 100 people in, so 50 of each. And actually, let's make it. Make it 100 each. Can you make it even that? Make it 1,000 each. That'll work. Okay, so let's say they had 1,000 each, and they test everybody. And they find out that 94% of the people that tested positive were in the control group, and 6% were in the treatment group.
Oh, okay, gotcha.
Then you have a 94% efficacy rate. Does that make sense? Because those who got the shot are not the ones getting the COVID. Okay. Okay, but I do need to move on because we have more to talk about. And but those are the main things. But I did want to talk about the control study, especially because that's the biggie this year. And I'm sure you all agree that of all studies that were done this year, that was the most important study of any study. Okay, maybe you don't agree, but I think so. Okay. Any questions at all before I move on to the next chapter, chapter 2? Okay, chapter 2 is about statistics and charts. Okay, and I'm going to do this one in a different way than I've just done. What I just did is I am going to ask you a survey, and I'm going to do it quantitative. Quantitative, you can do more statistics, it turns out. So here's the question I have for you. And oh, by the way, I have a rule. And the rule is you have to answer the question. If you don't feel comfortable, I can't imagine you not feel comfortable for this one, then just give me a number that at least is reasonable, even if it's not correct. I don't care about accuracy. I just care about, I want numbers. Okay. So how many minutes do you expect to be on Zoom, or Zoom like if it's some, Google Groups or something, over the next 7 days? And I want you to put in the chat box how many minutes, and I'm going to write them down because we're going to lose it. So 180. So put it in the chat box. And again, it doesn't have to be precise, just guess, that's fine. And by the way, if you know how many hours, multiply by 60. So 270. Keep going, I only have 2 answers. Everyone needs to answer in the chat box. Don't spend a lot of time thinking about it, just give me an answer. That's all I care about. It doesn't matter if it's right. Okay, 540. Okay, and by the way, the chat box is not part of YouTube, so this is all private. You guys can see it, but the world can't. And I'm not giving names. Keep going. I need some more numbers here. 1,000. Boy, you're gonna be tired. 240. Okay, 600. Okay, here's some more. Yeah, 300. Yeah, if you give me hours, I can multiply by 60. I'm very good in my head. 420. There's a few more. If not, then I'm going to get to it. All right, well, I need to get to it. Okay, so what I want to do is I want to show you a couple things. One is how to use a calculator. So I'm going to go to the LibreText calculator. Whoops. Let me do it one more time. I gave you general site. There we go. Okay, so here's the calculator that I created. And we're at the beginning of the class. I already mentioned random number generator. If you want to do that, you can do that. But I want one variable statistics. So I'm going to click on that. And then I'm going to type in the values separated by commas. So 180, comma. Okay, and by the way, feel free to open up a second screen and go to the LibreText calculator. And the easiest is to go to Canvas and click on the link because it's a really horrible long link. 180, 270, 540, 1000, 240, 600, 300, 420. Okay. This is a sample of the class. Hopefully you all agree. Okay, or sample students, whatever you want to. You should always identify the population, even though we don't know we don't know everyone, but you guys are all students. So I'm going to call this college students. So I'm going to say it's a sample, not the population. And I hit calculate. Did that look easy? Hopefully didn't look too hard. And that's it. Okay, I want to go through each of the statistics. So remember, a statistic is a number you get from the data. So let me then tell you the mean first. What is the more common word for the word mean? There's another word people use, but in our class we're going to use mean. Yeah, average. Okay, add them up and divide by the total. Okay, you're not responsible for doing the adding up and divide by the total. The calculator will do that for you, but you are responsible for knowing what it means. So the mean is 443.75 minutes. Okay. By the way, had I asked this 2 years ago, I think the answers would have been a lot different. What do you think? Okay, we're definitely in a new life. Okay, so that's the mean. Hopefully I don't need to spend a lot of time explaining what minimum is. Is that clear? Okay, minimum. Okay, then comes Q1. So Q1 is something you may not have seen before. Q stands for quartile. Okay, quartile, Q-U-R-T-I-L-E. Maybe I'll put that in the chat box so you can see it. Okay, and that is the 25th percentile. And what that basically means that if you list all of the answers, especially if you have a long list, then 25% of the answers will be at or below that number. Okay, I do want to give you a little warning. It is my biggest headache in all of statistics, personally, and that is the Agency of Statistics, the National Organization of Statistics, doesn't have an agreed upon definition. Isn't that awful? So if you use this calculator versus if you use a different calculator, you might actually get a different answer. Doesn't that suck? So I will not ever, I'm not going to ask you to compute the quartile and test you on the exact answer, but I want you to understand what quartile means. It means that about 25% are below that number. Any questions on that? Okay, median. This is something you learn in elementary school, but maybe middle school, but doesn't mean you remember it. You remember what median means?
It's the middle number. If we list the numbers from like smallest to largest, it's the middle one. And if there are two, we just take the average of those two.
Awesome. Somebody remembers their middle school math. That's awesome. Yeah, it's a middle number. So you first have to list them in order, because notice these numbers are not listed in order. These numbers are listed in the way they came to me. So you list them in order, and then it's the middle number. Okay, very important. Any questions on median? Okay, I want to mention something. Let's suppose that you're talking about house prices. Okay, these aren't house prices, by the way, but let's suppose you want to do a study on home prices. Okay, maybe, I don't know, in Tahoe, since that's where I live. Okay, so you want to look at house prices in Tahoe. And you're looking at the median and you're looking at the mean. They're not the same number. Even in this little example, they aren't the same number. Who is more interested in the median? What kind of person would be more interested in the median than the mean?
People that want to buy a house.
Okay, people who want to buy a house, and in particular, they want to find out what a typical house goes for. So if you want to just like the normal people in Tahoe, then the median is going to give you that idea. Does that make sense? Who might be interested in the mean for house prices? That'll be someone different. Here's a hint. I was once interested in the mean.
People that are employed that can meet a certain, what is the mean exactly?
Okay,
Sorry,
the mean
I
is,
live in a city, San
okay,
Diego.
that's fine. That's fine. The mean is you, as long as you mute after you ask, that's fine. The mean is you add them up and divide by the total. And the hint is not now, but at one point, the mean was really important to me. House prices.
So a median, and my internet is really breaking out, and I'm probably going to have to watch the video. I'm going to have to watch the video for 10 minutes. But
all right, let me do the following. Let me wait before you talk. Wait before you log out. Let me do the following. Here's a secret word. Okay, that doesn't mean we're done, but I figure that way you don't have to, rewatch the whole thing. So the secret word is data.
Okay, yeah, and to be honest, I mean, yeah, it's completely breaking out. I mean, so I can't.
And that happens. That's life nowadays. Sorry, I can't do anything for you on that one. If it was everyone, that would be a disaster. But it's just still bad for you. But at least it's not everyone. So secret word is data. So you all have it, and we're not going back to this. So make sure you write this down. Because remember, I don't put it at the very end. I put it somewhere towards the end, but not the very end. So that's your secret word. You can't miss it. But that doesn't mean our lecture's over, by the way. I strongly recommend you continue because what we're talking about is important. We're going to be doing a lot of this stuff. Okay, so now let's go back. We're done with the secret word. So let me tell you, because none of you guessed, I was a politician. Okay, and if you read my 3 Truths, 1 Untruth, I'm kind of giving it away, at least one of them. I was a politician for 9 years, actually. And one of the things that we cared about was the mean. And the reason is something very important is we had to look at tax revenue. And if you don't know about Tahoe, I'm going to tell you, there are some amazing houses that I could never afford that sit on the lake and have a great view, and they're, 7 bedrooms, and, literally we have $50 million houses here. Okay, just amazing. But there's not a lot of them, but there are some. And that is going to skew the median far to the high side. So the median home price in Tahoe might be $1 million. The mean home price in Tahoe might be $1 million, but the median is more like 600,000. Okay, it's still expensive here, by the way, but it's not $1 million for just a normal house. If you want to just live in a neighborhood.
Can you repeat that again? How did you get to the mean of $1 million? And then also, yeah,
Okay.
I am every couple seconds I'm like.
Okay, so yeah. So the idea is the median is like 600,000, and that's because if you list all the houses for sale and take the middle one, that's about $600,000. But there's that one super house, okay? And in fact, the lead singer of Kiss, just from my age, some of you are younger, but one of the main bands in my era, just bought a house here for I think around $50 million. And that one house is going to just skew that mean way up high.
Oh, I see. Okay, yeah. And also, I wanted to say my dad's ex-partner's sister-in-law's sister was married to Clarence Clemens, who was Bruce Springsteen's saxophonist.
Yeah, and again, these fancy people can afford a super house. Okay, I can't. By the way, I'm a teacher, but I can afford a house, just not a super house. So anyhow, the mean is for the people in politics, so the city council, school board, all that, where you might be trying to raise money using taxes, they care about the mean, because that $50 million house, if you look at I think it's 2% tax rate, that brings in a lot of money in. So they care a lot about that. And the median isn't very interesting. The mean is interesting. So it really depends on who you are and what you're interested in, on whether you care about the mean or you care about the median. Any questions on that? Okay, Q3. So Q3 is similar to Q1. Any guess on what Q3 might be, given that Q1 was the first quartile? Hoping all of you can guess. It's not a trick question. What do you think?
Maybe the
75th percentile, third quartile. So it's a third quartile. So 325, 3/4 is 75 cents, right? That's what most people can think about. Okay, so the third quartile is the 75th percentile. So basically 75% of the data is at or below that number. Does that make sense? Okay. The interquartile range, by the way, is the range between the first quartile and the third quartile. So it's between 255 and 570. So sometimes you'll say the length of the interquartile range in this case would be what, 515 if you subtract the two numbers. No, sorry, 315. Sorry about my bad arithmetic. So if you take Q3 minus Q1, that gives you the length of the interquartile range. Okay, any questions on that? And that gives you the range of the middle 50%. So the typical group.
It's interesting how, you know, the most expensive house can completely throw off the whole market. So in other words, that's why the mean is much different than the median.
Exactly. An outlier, which I'll tell you in a moment, will make that happen. So you've heard the word outlier, but you probably haven't heard the definition. I'm going to give you the formal definition in a moment. The maximum is 1,000. I think you all can understand that. I hope, right? That's not a fancy word. Then there's the standard deviation. Okay, I want to double highlight this. So standard deviation is the key difficult statistic in the first half of the class. And what it tells you is how far apart the data tends to be from the mean. So it's kind of an average distance from the mean. So the standard deviation here is about 267. So that means kind of on average, people are spending within 269 minutes above or below the mean of 444 minutes. And that's a standard deviation. Okay, very important. So let me give you a example I like to give. Let's say I told you, okay, and this isn't even told you, I would love to have almost everyone pass this class. Okay, that's really what I want. Okay, you probably want to get past too, right? What if I told you that the average percent for the course was 73%? Am I reaching my goal? Is almost everyone passing? Any thoughts? And remember, 70% or higher is a pass. And if I told you that the mean was 73%, is almost everyone passing? Any thoughts?
No.
Okay, it's a trick question. The answer is I haven't given you enough information. Okay, if I told you the standard deviation was 0.1, then everyone passed the class, because the average distance is only 0.1% from 73%. So 70% is like another galaxy away. Do you see that? But if I told you the standard deviation was 20, then you can have a whole lot of people far away from 73%, and you can have a whole lot of people way below, in fact. And a lot of people didn't pass. Do you see that? So the standard deviation really gives you an idea of how spread out the data is. Is it all right there where the mean is, or are they all over the place? Any questions on that? Okay. And in particular, I'm going to type this out, the z-score. And the z-score is the mean, the x value minus the standard deviation, minus the mean, divided by the standard deviation. And I'll be typing that and hitting enter. Okay, so that's in the chat box. So the z-score, or z, is x minus the mean over the standard deviation. The mean, by the way, we use the Greek letter mu. Standard deviation, we use the Greek letter sigma. You'll get to see that in a long video. I can only do so much in an hour and a half for the whole week. So you'll get to see that in other places, the symbols and stuff, and in the book. So that's a z-score, and it tells you how far away something is from the mean, kind of relative to the population. If the z-score is bigger than 2 or less than -2, we call it an outlier. Okay, so I will tell you that $50 million house is an outlier, definitely. Okay, I don't know the z-score in particular for it, but I do know that it's going to be bigger than 2. It's a super house. Okay, any guess on what my house's z-score might be? I'm a teacher. Any thoughts? No one wants to guess? I know all you can see is a wall in the background. But I'll tell you, it's probably about negative 0.1. What does that tell you about my house? Any thoughts? So it's negative point. What does it tell you that it's negative first?
It's below the mean.
It's below the mean. Okay. Okay. I don't live in a super house, by the way. I'm happy with my house. Okay. Okay. Not costs half of 600,000. That would be a much lower Z-score, by the way. And negative 0.1, 0.1 is really close to 0. So that means it's only a little bit below the mean. So I have an average house, slightly below average, but not much. Okay. And that's it. That's my house. Okay. So I'll tell you that. I love my house, but you know, I don't have the view of the lake or anything like that. Okay. But I don't live in a slum or anything like that either. I'm normal. Okay. Any questions on that idea? Okay. Here's another example. It's one I like to use. My SAT score, which I guess they're doing away with, but you've heard of SATs, I think. My SAT score was 1,260. My daughter's SAT score was 2,020. Who did better on the SAT? Can you tell me? The answer is no. You can't tell me. Okay, unless you really know a lot about the SAT, because as obvious, my daughter and I are different generations by definition, right? Since she's my daughter, and scoring was different. It's meaningless for me to tell you my SAT score because you don't know anything about the SATs in the 1980s. Okay, so that is a meaningless thing to say, to tell you what my score is and my daughter's score. It tells you nothing. Okay. But if I told you my SAT score, Z-score, so the Z-score for my SAT was 2.7. And my daughter's was 2.5. Okay, what does that tell you?
That you both did very well, much above the average score.
Right, we both did very well, much above the average score. And but mine was a little better. I could brag. That was my daughter, not much better, a little better than my daughter's. And what university do you think you could get into with a Z-score of 2.6, 2.5 even? Let's say in California.
What kind of GPA is that?
It's just a Z-score is all you need to know. Z-score is 2.5. What university do you think she can get into? Or she got into? Any thoughts? Okay, not hearing. She went to UC Berkeley. Okay. Yeah, Stanford. Actually, she didn't get into Stanford because you actually have to do something special, and she didn't do anything special. Okay. And I didn't get in either. But we had high GPAs and high SAT scores, but we didn't do anything that special. But she got into UC Berkeley, and UC Berkeley only accepts those with a high Z-score. Okay, and the Z-score is what matters. Does that make sense? Because you have to be better than a lot of other people. Okay. Okay. Your stepdad did. My sister went to UC Berkeley Law School. That's cool. They could have been students together. Okay, any questions at all on the Z-score idea? Okay, the variance we're not going to do much with. That's just a square of the standard deviation. I want to give you a heads up. In the project, don't even talk about the variance. If you think you understand it, you don't, because we're not doing it. Got it? But some classes want it. I think it's so unimportant that we don't do it. unless you're a mathematician, which that's not what this class is about. IQ I've talked about, that stands for interquartile range. And I hope I don't have to say much about sample size. There are 8 people that answered the question. Any questions about looking at the data and looking at the statistics that come from the data? Any questions about any of the statistics? Okay, so notice, just a note, z-score and percentile are somewhat similar in that they give you a relative score. So for example, if you're a nurse and someone comes in, delivers a baby, and the baby is in the 4th percentile, what does that tell you? In weight, let's say in weight. If the baby's in the 4th percentile, what do you know about that baby and you're a nurse and they're in the hospital? Any thoughts?
The baby's underweight. It's on
Yeah.
the bottom 4th percentile.
Exactly. Baby's way underweight. They're probably going to need some special care and extra exams and stuff. So what you can do is you're going to look at the percentile, and based on the percentile, then you know whether you need to do some extra treatment. If they're in the 40th percentile, you say, okay, fine baby. Do you see that? So percentiles and z-scores kind of give you similar information. Any questions on that? The math is very different, but I'm not getting into the math. I'm going to say that a lot in this class, by the way. This class does not require calculus, so I can't do a lot of math. Okay. If you really want, I can show you in office hours and you'll cry because it's really hard. So I'm not going to get into the math of all of this stuff. But there is math. You can trust me. Any questions on the statistics? Okay, I want to show you the spreadsheet. This is what you're gonna. This is how you're gonna use. This is what you're gonna use for the project. And let's do another one. I don't think I want to do a survey because it'll take too long. We don't have much time. So I'm just gonna throw in some numbers. Pick some fun numbers. So how about 3, 3, 4, 4, 5, 3, 6, 3, 2, 7, 3, 4, 3, 5, 4, 1, 1, 1. 1, 1, 1, 2, 2, 4, 3, 8. How about 6? Okay, so one thing is the spreadsheet also gives all the statistics I just mentioned. But the other thing the spreadsheet does is it gives you some charts. And hopefully it's safe to assume you've all seen a histogram. It's a special kind of bar chart. It's a bar chart such that the x-axis is quantitative. So the variables have to be quantitative and not qualitative. And the widths all have to be the same. So here's an example of a histogram. Notice that there is one highest bar. Do you know what you call the highest bar? Starts with an M. You also learned it in middle school, which means you probably forgot. You remember? I don't see y'all jumping in. It's called the mode. So the mode is the most frequent answer, or the most frequent bar if it's that way. And so the mode is at least the interval from 1 to 2.5. Also notice that you have the highest bar and it kind of goes tails down from there. And if it tails down to the right, we call it skewed right. If it's a reflection of this and tails to the left, it'd be called skewed left. Any questions on that? Okay, just a note, there's some others. If I go to stats and I go to box plot. Okay, and I want to give you a warning. If you do this at home, it might give you all kinds of security warnings. I promise you, I did not put any viruses on this when I coded it. So you won't get a virus when you use it, but the computer may warn you, you might get a virus, you sure? So you're not going to get one. So this is called a box plot. And what it does is it gives you what's called the 5-point summary. So there are 5 numbers that go on here. The minimum that's right here, is 1. Then the maximum is up here at 6. Then the median is right here at 3. And then down here, 1.75 is the first quartile. And then at 4 was the third quartile. So it gives you a picture of those 5 numbers. And the main thing is you can really visualize and see the interquartile range between 1.75 and 4, because that's the box. Any questions on this? Okay. By the way, these bottom words, or if you're blind, you can still hear the box plot. That's why I put the bottom words on. But this is another chart, and you are responsible for knowing how to read this chart. Any questions on it? Okay, if I go to stats again, actually, this one won't work, so let me put some more numbers in. Let's start again. Let's get an example that will work. It's just more typing. I'm just going to throw some numbers in. Okay, here's a bunch of numbers. And if I go to stats again, and I go to stem and leaf. Oh, I forgot to check something. Let me check it again. Sorry, with Zoom, it's really hard to move things. I'll get there. Not letting me move it. Sorry, your pictures are all hiding when I'm looking. I can't even see it. So I'm trying to move the zoom and it's not letting me. There we go. Nope. Let's see if that worked. Let's try this. Huh. All right, one more try. Another idea. Sorry about this. There we go. I don't know why it wasn't letting me move things. Still won't let me move your pictures. There we go. Okay. So this is a stem and leaf plot. And what it does is it keeps the data. So we still have all the data. And you'll notice the left part of the table are the tens digits. And the right part of the table is the ones digits. And so we can see, for example, this number right here has a 2 for the tens and a 3 for the ones. So that corresponds to 23. So the nice thing about the stem and leaf is you don't lose any data values. You can still see everything. Whereas for the box plot, you lose all the data values. For the histogram, you only get ranges of values. But for stem and leaf, you have all the values. It's all there. Any questions on that? Okay. And you could see, for example, the true mode is actually 12 because we can see there are 3 2s in a row here. And there's nothing else with 3 in a row. Okay, there's something with 2 in a row, 44. Any questions on reading this chart? So this is another chart that helps you visualize data. And there's lots of charts. You've all seen pie charts, so I'm not spending time with that one. But I wanted to give you kind of the 3 main ones for this class. And that is the histogram, the box plot, and the stem and leaf. Just one note, if instead of being skewed, like this is skewed right also, if you have the middle being the mode, and then it trails off on both sides. So you've all seen this at the beach. If you go to the beach and you just slowly drop a bunch of sand, you're going to get a mound. And the middle is going to be the tallest part, and then it's going to trail off at the left and right. Then we call that normal. Okay, there's some heavy math involved. We're going to have an entire chapter just on the normal distribution. So it is the distribution for this class. And just normal means that it is unimodal, one mode in the middle. And it is not skewed left, it's not skewed right. It just has slow tails on both sides. Any questions on that idea? Okay, so again, I can only give you highlights. There's a lot of information, but what I found from my experience is that chapters 1 and 2 are not the brutal chapters in this class. A lot of little details, nothing, no concepts that are that tough for most people. But I want to give you a warning. Chapter 3 is the brutal chapter. So that's next week. So just let you know, we're going to be doing probability next week. And not everyone, but a lot of people have a lot of trouble with it. Chapters 1 and 2 is not where people have the difficulties. So, but I want to give you the heads up about next week. Next week is going to be a tough one. I am going to now formally stop the share because I have gone through everything I need to say. And again, I want to warn you, I have not covered every little tiny detail because there's a lot of little details that aren't hard. So make sure that you read the chapter and make sure that you watch the full, the videos and do the homework and all that kind of stuff. But what I can do, as always, I'm gonna stop the recording.